Thanks for coming. Our presentation is Plunder, Pillage, and Print, the art of leveraging multifunction printers during a penetration test. My name is Pete. This is Daryl. We work at Rabbit7 on the penetration team, where we do pen tests everywhere from web application to network style penetration tests. We've worked together for the last 5 years and so. 5 years. The agenda for our talk is, first we're going to discuss the multi-printer attack vector, kind of what it is and why we chose it. We'll give examples of the attacks, along with how we're automating these attacks, and then we'll wrap up with how we can reduce the risk of these attacks. I'm going to hand it over to Daryl here to talk about why we chose multifunction printers.
Thanks, Pete. So a couple quick questions. How many people in here are actual pen testers? So we get a hand. Okay, so how many people in here protect networks? Responsible for protecting your networks. Good. So what we're going to give you out of this is we're going to get the pen testers and we're going to show you how to extract data from multifunction printers that should be able to give you access to Active Directory. That seems to be the predominant environment that we gain access using these attack methods. And for those who are actually working on protecting their environments, we want to give you the information to stop us from doing these evil things to your network. So what is this all about? What are we trying to accomplish here? Start with what we're after is usernames, passwords, and of course the purpose of that is to gain shell. Isn't that what all pen testers want, right? So shell, yeah, that's what we want. That's what we live for. If we don't get shell, we're like not happy. So we're after shell. So let's go ahead and look at this a little bit from a historical standpoint. So me and Pete started doing this back in 2010, developing these methods and these attack vectors to start leveraging them as part of our job. Back then, we were able to gain access approximately 10 to 15% of the time. When I mean access, we were able to extract usernames and passwords from multifunction printers that we could use to gain access to Active Directory environments. So let's jump forward, 2014. It's changed a lot. Now this attack vector works 40 to 50% of the time. So why does it work 40 to 50% of the time? So a company goes out and they buy themselves a multifunction printer, and they're expensive, $8,000, $10,000, $12,000. Even some of the Xerox collar cubes run upwards of $20,000. And back in 2010, companies were doing this and they were using them to print with. They weren't using all the added functionality and features that exist on these multifunction printers. Well, those days has changed. It's 2014. Companies are actually leveraging the features and functions on these printers to that level. They're integrating all these different functions. The problem is they haven't actually changed the security. So since the security's never changed, now we're able to leverage them integrating these into their business environment to extract these credentials 40 to 50% of the time. So why multifunction printers? Well, how is this possible? Well, multifunction printers contain some interesting information. An example, they contain username information. So if you look at collar printers, they have a log, a collar log. This is typically used for chargeback functionalities. If departments want to be charged back for the usage of color, so they contain that information. We also have this function called scan to email. Your employee walks up to a multifunction printer now. He can actually log onto the multifunction printer, he can pin himself in, and he can do a scan job and send it to the email. Because of that, these devices have to be able to integrate into your email systems. What about scan to file functionality? Same thing. The user wants to save a copy of something, he can scan it on this printer, have it saved to his laptop, his desktop, a file server, those type of services. And of course, for him to authenticate himself to these devices must be able to integrate with LDAP. So again, LDAP information is contained on here. And of course, the last one is a little more aggressive, remote firmware upgrades. There's been a lot of findings over the last number of years of attacks via the firmware upgrades. So we're going to be talking about that also. So at this point, it's kind of game over. We're going to gain access to these devices, we're going to extract data, and hopefully we're going to show you how to do that. So moving from here, let me turn this over to Pete. He's going to talk to you about plundering printers.
Thanks, Daryl. So Plunder, what can we plunder out of a printer? What type of information can we gather that would help us on an assessment? We're looking at kind of pulling user data. Information we're looking for are usernames, applications that the users may be using, along with any host names that may be given up by the printer. So some examples, Dell printers, they like to give up usernames, application, and host names. All these can become very valuable to us during the assessment. Xerox and HP devices just give you the application, the usernames. So let's take a look at a couple of these examples. First example here is of a Dell printer. The first column, the job name, gives us a good indication of what applications the users may be running in an environment. Here we see the first one is Microsoft Outlook. Somebody printed a memo. The second one is kind of a very intriguing one. It gives us some good information about the operating system. We can see where the user's path is. Anybody know what operating system uses C users for a path? Yeah, Windows 7 and higher, or at least Windows 7 and higher. So now we can target attacks against an environment where we know they're using Office products such as Outlook and Word. We can also target the operating system, which is Windows 7. Now we look over at the owner column. We can see the username here. So not only do we have 3 valid users that we may be able to use for a brute force attack, we also see the name structure that they use to create their usernames. In this case, we see the first name, or the first initial of the first name, followed by the last name. Now what we can do is, say for instance, take the top 100 first names and the top 1,000 last names and build a list that we can use to attack Active Directory to see if there's any weak passwords such as summer 2014 or something to that effect. So another key bit of information that we can gather to help us attack in the environment. The last column here is the host name. In some organizations, they are very specific with the host names. It gives us a good idea of what that host does. In this case, these 3 jobs were submitted by what looks like a print server. We have PRNT SRV01. Okay, that's a print server. So we can kind of get an idea that, okay, they're going to label their devices based on its functionality. In some cases, we may see hosts like, take for instance the first one where it says mbolton-laptop. Well, that gives us the idea that this may be a mobile user. Great. What do mobile users usually do? They have some sort of remote access. This would be great for a phishing attack where we can say, hey, look, we have a new VPN that we're setting up, log in here to test it out, make sure everything's great. Well, we have a fake site that's just harvesting those credentials. So as this one basic function of the printer, we're able to gather a lot of information to hone in our attacks. Oh, and by the way, all this is done anonymously and usually flies under the radar of any IDS, IPS monitoring system because all we're doing is making a normal HTTP request. We're not authenticating, so there's not any failed login attempts to be monitored. All we're doing is a simple web request looking at this job information. Next example is of a Xerox printer. We get the same type of information minus the hosts. So we can see in this organization they're using crystal reports. Again, another attack vector we can leverage on the client side. We also see, Microsoft Word. A lot of organizations use Word, use Windows operating systems. It gives us a better idea of what they have in an environment so we can hone in our attacks. And we also get username information. In this case, they're using a different format. They're using the first name followed by the first initial of the last name. We have 4 valid accounts now that we can submit attacks against, and we also know what the format they're using for their username so we can create our own list for additional brute force attacks. The last example I want to cover here is an HP. This example actually comes from an assessment I did where it was a banking institution that had a pretty locked down environment. What I did is I ended up going through all their color printers and enumerating users, pulled out all that user information, and then submitted those users using some basic bad passwords like password 1, name of the season followed by the year, and I was able to gain access. It allowed me a foothold in the environment. Lucky for me that all the users were part of the local admin group. So once I was able to get that user account, then I was able to access all the systems. And then once I was able to access all the systems, it's just a matter of time before you find that domain token laying around here, or you're able to, domain users logged in, you can use Mimikatz to dump the clear text password. But in the HP, we see the same type of things. We see the user's user ID here and the format that they're using along with the applications. And in this case, PDF stands out to me like a bullet. It shows that they're using either some sort of Acrobat reader, which is notorious for remote exploit type of stuff, or they're using maybe some other third-party Acrobat or a PDF format reader like Foxit or something, which also has vulnerabilities associated with it. So based on all this information we're able to gather from the printer, we're getting a pretty good idea of what the environment looks like. We get a good idea of what attacks are going to have better success rate than other attacks. So now let's talk about pillage and how we can pillage printers. I'm going to hand this over to Daryl to start out with.
Thanks, Pete. So pillage. Now that we've gone through the basic plundering, we've showed you multiple ways to get username information, application information. We're going to ramp up the attacks a little bit. We're going to start doing some vicious pillaging, which is always fun. So we're going to start off with address book attacks, being able to extract critical information from multifunction printer address books. Typically, multifunction printer address books, and we all understand they probably contain what, usernames, email addresses, stuff like that. But the one key thing is they contain passwords. There's a number of products that actually will store passwords in the actual address books. The couple we're going to talk about here is the Konica Minolta and the Canon Image Runner advanced versions. Now, of course, the Canon image runners that predated this also had a similar problem, so it's basically all the Canons. So to start off with the Canon image runners, it turns out these particular devices, the newer and the advanced versions, the only way to get the passwords out of it, you have to tell the printer to do this. There's a special setting you have to go into the printer to set to tell it to give us the actual passwords. Also, once you start exporting the passwords, it's going to prompt you, or when you start exporting the address book, it's going to prompt you to actually enter a password, and it's going to encrypt the data. So it's going to give us the passwords, but it's going to be encrypted. Well, fortunately for us, the way they designed this is the control of that encryption is at the user's level. So as part of the post process to make this request, we can alter some settings that will give us the ability to extract the passwords in plain text. So let's start with the first example. And as we see here, with the Canon advanced version, we have a setting right here, include passwords when exporting the address books. So we got to enable that. So we turn that on, we go ahead and click OK, and we move on. When we get ready to extract the address books, it's going to prompt us to put a password in there. We're going to enter this password, and that's going to be used as part of the encryption mechanism to encrypt the password. So we go ahead and start the export, and instantly we're able to dump the address books, and as you see, the password's encrypted. This is actually a base 64 of the actual binary encrypted password. Of course, it's base 64, so it would be transferred in a text file. So we step back and go, okay, well, this encryption doesn't do me any good, and personally, I really stink bad at decrypting stuff. So we dug in it a little more and took a look at it. So it turns out during this post process, it has this setting called ENC mode. So what do you think that means about encrypt mode? So what happens when we change this encrypt mode to 0? Well, it's real nice. It gives us what we want in plain text. And not only that, I mean, let's take a look at this. We've pwned them. What we have is we have the system server name, the location of the share, the entire path, the domain name, the username, and the text or password in plain text. Now we're actually in the domain as some level of user. Now this can vary from just an individual user's account all the way to something that's elevated that has access to a lot of different settings, or in some rare cases may actually be a domain admin account, which we do encounter a little more frequently than what you would expect. So let's move on to the next one, the Konica Minoltas. In this case here, we're not really extracting the full address books. We're extracting certain aspects of that same area of data, and we're parsing it out a little better. So here we can export the address book or the information out of the address book associated with the specific password. And when we originally found this, it was kind of interesting. So if you go into the web interface on this device, we weren't finding anything really useful that we could extract. But one of the guys on the previous team I was on, Joe, was playing around with one of these, and he found out that Konica has some management tools, management applications that you can download off their site. And that's used to manage all of their products. And you can put plugins into those to manage every different version of Konica Minolta device. And what he did was he piped all this data through Burp, and he captured all the data and sent it off to me. And it turns out it was doing all this through SOAP. So it was doing SOAP messaging, making requests, getting replies back. And it was doing this over port 50,001 and 50,003. 50,003 being the SSL, actual SSL port. So let's look at the SOAP messages associated with this. Start by getting my head out of the way. So if we look at this SOAP message, literally you could take this SOAP message right here and play this right against the Konica printers. And what it's doing is carrying out an authentication. We have the admin and then the password of 1, 2, 3, 4, 5, 6, 7, 8, which is common for a large number of the models. And what this does, it's actually going to give us what's known as a session key or auth key. So we send this off to the Konica printer to port 50,001, and it replies back with this SOAP response, and it gives us this auth key, which basically is functioning as a session cookie, for no better terms. So we take that, and then we can play that back against the system with another SOAP message. And this is under operator info and a brief list condition. And what we do is we path that auth key back to the device. We also want to make sure our major minor versions are accurate, because it seems to be based on the patch level of different printers that does change. So we have to get a response back from the printer and make sure that we match those up correctly. But if we send this SOAP message off to the printer, it's going to respond back with this information here. And in this case here, it's an SMB, so it's Samba, it's a Windows connection. Gives us the host name. Gives us the user name, it gives us the password in plain text, and the actual folder. The information that's turned within this SOAP message is going to be SMTP for scan to email functionality is being utilized, SMB, Samba, and also FTP services. So again, we quickly are able to own an environment by just requesting the information. So have you seen so far, the key indicator to this whole thing is we haven't really done any serious vicious hacking. We've just been nice enough to ask the printer right. It's pretty simple. You know, so if you ask the printers right, they're nice enough to give you all the information you need. And of course the other key indicator, if you haven't noticed, is we have been using default passwords. So that makes me want to ask one question here. How many people in here, as a requirement of your business environment, before any multifunction printer is deployed into your environment, that the default factory passwords are changed? Okay, that's pretty good. Everyone look around and look at the hands that are up. Okay, that seems to be about the right number. You know, it's a very small percentage. We're not doing that. And when you don't do that, people like us, hopefully it's people like us, can be able to pull this data out of your systems. Or it could be somebody more evil, has more evil intent, can pull that data. So be thinking about that moving forward when you're going to secure your environment. So moving from here, I'm going to turn this over to Pete, and he's going to talk to you about an attack we use quite regularly known as a passback attack.
So another attack that we use to pillage printers is called a passback attack. What the passback attack does is it targets the authentication services of the printer, like Daryl was talking about. We have LDAP, which is used to sync to an LDAP server to pull email addresses and such. We have FTP, Windows file sharing, and SMTP. So let's break down kind of how the passback attack works and how you can use it to get information. So we have our normal multifunction printer here. It's set up to authenticate to an LDAP server to pull email address information. So what we have is we have an IP address for the LDAP server. We also have credentials, a username and password that's able to query the Active Directory. In this case, we'll use Active Directory to query Active Directory and get the user's information. So once the printer authenticates to the LDAP server says, okay, you got a valid username, valid password, here's my data. Great, printer populates its stuff, moves on, does its business. So how can we take advantage of this? How can we intercept those credentials or get access to those credentials? It's pretty simple. All we need to do is log into the management interface, find the LDAP server setting, and change it to our IP address. Then what we do is we say, hey, printer, go search for this address, see if you can find an email address so I can send this document. The printer says, all right, let's do it. Then sends me the credentials in clear text. So So let's walk through the example here on a Xerox device. The reason why we've picked LDAP is because it's the most common functionality we see configured in most environments. And usually it has a significant level of privileges. We can either use it to enumerate users, and in some cases it actually has access to systems within the organization. So in our first example here, we're going to cover Xerox Color Cube. First thing we want to do is log in as admin. Usually default password is 4 ones, and if we can't get that default password, a default password doesn't work, we got a way to get that for you guys. Next, we go and change the LDAP settings. We point the LDAP server to us, we start up a netcat listener on our system, and then we issue a search under the user mapping function. So here are the screenshots that show where all these settings are set up. On the left here, we'll see the LDAP configuration. Click there, you access the LDAP screen. Underneath the LDAP screen, you see the IP address. This is what we want to change to point to us. And then underneath it, here are the creds that we want to get. In this case, we can see the user's SVC Xerox. Really good label. Now, we set up a netcat listener on our machine, getting ready to listen for this connection. So what we do is under the user mapping tab, which is here, we use the search functionality and we say, hey, look up user foo. The printer says, all right, I don't know who that is, let me go find out. Oh, hey, I see this LDAP server, let me go talk to it. And what do we see? Bam! We now get the username and password sent to us over in clear text. Thank you very much. As Daryl was saying, you asked nicely, it gives it to you. And a lot of this stuff, I mean, it's not going to be seen, and it doesn't look like it's malicious, because this is normal traffic that happens during the day. You know, the printer is going to be talking to an LDAP server. The only way we can kind of find that information is if we dictate, here's our LDAP servers, this is the only server that these printers should be talking to and such. The next attack we're going to talk about is on a Sharp device. Same type of attack where we're attacking the LDAP authentication system. We log in as administrator user, most cases, it's just admin, and like we saw the raise of hands, most people don't change that. We access the LDAP settings, we change the IP address again to point to us, set up our netcat listener, and then issue a test connection. Once you log in as admin, you'll see this drop down for you. And if you go underneath the system settings, there's an option to access the LDAP settings. Here are the LDAP settings. Right here's this IP address for the LDAP server. If you notice, the difference between the Sharp and with the HP or Xerox is that we only have one LDAP server. Xerox had a backup LDAP server. That happens as if the first one fails to communicate, it fails over to the secondary one. Here are the credentials we want to capture. Another neat feature of the Sharp is this test connection. So once we execute the test connection, it sends the credentials. The nice thing about the test connection is it just goes to verify that it can actually talk to the device. None of the changes that we have made are permanent. The only way to make it permanent is by clicking on the submit button down there. On the Xerox, to get it to work, we actually have to submit those changes. So once you would initiate a passback attack on the Xerox device, you have to go back through, clean it up, put the old IP address in, clean up your tracks. So once we hit this execute, what do you think is going to happen? The printer's going to say, hey, how you doing? Here are my credentials. As we see here, we get the administrator ID and we get the password. The question mark and the 0B are just extra binary data that gets sent along with the Sharp. So now that we've discussed how to pillage, let's talk about how to print.
Thanks, Pete. So dealing with printing. So what we're going to talk about here is, it's pretty straightforward. You know, we wanted an attack that, of course, the presentation is about plunder, pillage, and print. So plunder was evil, pillage was evil. Well, how can we make print evil? Well, our goal here is actually be able to create, for no better purposes, a print function, or be able to send something to port 9100 and actually take over the printer. So we're going to do what's known as a Xerox Workcentra firmware attack. Well, this one's kind of interesting. So let's start off right here. So if you go out to Xerox, and the story goes, I'll give you the whole story of what I did. So I went out to Xerox and I downloaded a firmware package from Xerox. If you get a firmware package from Xerox and you open it up, you'll see this header. It starts with XRX begin, goes to XRX end. If you remove that, their firmware package is nothing but a tarball. Okay, so you can completely untar the whole thing. So once you untar that and you start looking in there, you find some interesting information. The firmware packages, for one thing, are known as DLMs, dynamically loadable modules. These dynamically loadable modules, and we open it up, we strip the header off of it, we untar it, and we find this folder called opt-nc DLM toolkit. And inside that toolkit, we find some interesting files. How about a DLM maker? DLM stripper, the stripper actually strips the header off. And what about key files? So the whole signing process for a DLM, dynamically loadable module, on a large series of Xerox work centers up until I told them about how I did this, was synchronous keys instead of asynchronous keys. So there's no public-private key pair. It was a single key, and that was used to sign and validate signatures also. So if we take that DLM maker and actually run it, we actually get the command structure. So what have we got so far? So we know that Xerox firmwares use dynamically loadable modules. We know Xerox firmwares contain a DLM maker and all the signature keys for signing firmware packages, and also all the instructions to help you build your own firmware package. So it's pretty straightforward and pretty vicious. And you kind of wonder, why is this stuff in there? Well, one of the key reasons why a lot of this stuff in there is the cloning function. So Xerox printers have what's known as a cloning function. Cloning function makes it possible for you to make a copy of one printer's configuration and take it to another Xerox printer and install it. So you can generate a clone, take that, and send it to printer port 9100, and it'll actually reconfigure the printer. So it makes management on a large scale of Xerox printers very easy. The problem is the single signing certificate for signing these things. That was the failure there. And that's why they contained the software, because they had to be able to build a DLM and also extract a DLM. So what we're going to do is we got a demo. So we got a video demo here. It'd be nice to have done this live, but that's not always doable. I have trouble getting people to lend me $15,000 printers. I wonder why. So when we start here, we got several key pieces here. We have the actual printer, so we're logged in through the web console of a Workcentra 5740. Right here, pretty straightforward. So we can see the job coming in. And we got two windows. Up here, we're going to open up Netcat Listener on port 8686. And then here, we're going to send our own personal firmware package over here to port 9100 using Netcat as a redirect. And port 9100, let's pause this for a second. Port 9100, obviously, is the standard JetDirect printer port. So there's no authentication. So we're getting multiple failures here. One, they gave me their firmware build kit. They gave me their keys to sign their own firmware. And they gave me a way of delivering it to the printer without ever having to authenticate. So it's definitely total failure here. Another piece of information is the firmware packages. When you install a firmware package on a printer, what it does is the entire firmware package hits port 9100. It'll validate the signature, and then it'll explode it off onto the printer. And then it'll kick off a bootstrap program. The bootstrap program is nothing but a shell script, a .sh shell script. So what we did was we created our own firmware package with just the shell script. In this case, we created a firmware package with a bash shell in the shell script. And instantly we're able to we're root, as you can see. We're able to gain root access. If we look at the print job on the actual printer, it will show up, and shows up as a decomposing printer, print job, so that we're attached to the printer. and a couple other interesting things on here. So if we look at this data, we can quickly see what operating system that the printer's running. In this case, it's running Linux 2.6. This happens to be run on a PowerPC. The Linux version happens to be a Wind River Linux version. So if we pull up the CPU information, we can see in this case that it's a PowerPC. As you can see there, it's a 500V2 PowerPC processor. But the other most critical item here that I want to talk about here, we'll stop this as soon as this comes up. Okay, this particular folder right here. So we look at cat var opt nc config secure.cfg. So we have this passback attack, which Pete talked about, where we can actually get LDAP settings, Samba settings and stuff just by telling the printer to connect us versus its normal source. We can capture that in plain text. And as Pete mentioned, that if someone's changed the password, so 1111, you know, admin 1111 is not working on the printer, how do we get the password? So we come back to this attack here, and now I'm root on the actual printer. So it's definitely failing for him, really bad. And it turns out that all the other passwords, the LDAP, the Samba, all the stuff that's used to authenticate the devices is encrypted in storage. And I haven't had the time or access to be able to figure out the decryption. But in this case, why should we have to? Because the LDAP works fine. You know, we just ask it and it gives it to us in plain text if we do the passback attack. But there is one password that is not encrypted, and that is the admin console password. And that happens to be stored right here in this file on the printer. So if we speed this along right here, open up the file, and we see right there it is. In this case, it happens to be the default, but yet we can pull the plain text password for the administrative console, and then we could use the passback attack to launch further attacks against the system to pull LDAP settings or Samba settings or SMTP settings and get the data in plain text. Okay. So, if you're interested in further details on that firmware attack, here's where you get the white paper. This white paper will give you all the detail you need to actually do all this stuff. It'll tell you where to get the right DLM to download. It'll tell you how to extract it, because there's certain DLMs, if you download and the system happens to be a PowerPC, then you're going to have a PowerPC to run the code. It turns out that there are some x86-based Xerox devices that we're able to pull down, and this code will just run on an Ubuntu system without a problem, or a Debian system, the DLM maker, without any problems. And here are the systems that we validated. I think most of these are actually vulnerable to this attack, which is quite a few of them, and I haven't tested all of them. But yeah, that's definitely the stuff to check out right there. So moving from there, let's go ahead and talk about how we automated this. Let's talk about the Preda, the Metasploit, and what we're coming up with in the future. Go for it, Pete.
So just before I switch slides, everybody get a picture of that slide? Anybody need it again? Awesome. So now that we talked about all these different ways to launch these attacks, as you saw there, a lot of it was manual. So if you have an environment with hundreds of printers, it does become very time-consuming to go through each printer to try to find what information or which printer has the good information that you're looking for. So this is where Preda was born. Preda is an embedded device harvesting tool. What it does is it enumerates devices based on a fingerprint. The fingerprint is based off of a title page of the web server type, and SNMP information. So how does Preda work? Well, first you run your default Nmap scan, so you figure out what's in the environment. You take that information, you feed it into Preda. Preda also supports the CIDR notation, a list of IP addresses and a port and such. So what Prada does, it goes out and scans the network. It starts fingerprinting these devices based on the information, SNMP, server type, header fields, that type of stuff. Once it finds a matching fingerprint, so as an example, let's say, hey, this is this type of HP desktop printer. We know that we can enumerate usernames from it. There are corresponding modules that have the way to actually enumerate that information out. So Prada says, okay, I have this fingerprint, I know it uses that module, now let's run this module. Let's start gathering that information. So it goes out and gathers the information for us, be it usernames, passwords, address book extractions, LDAP attacks, whatever. Whichever the module says to go do, it goes and does it. It gathers that data and then logs it for us for future use. So how do we use Prada on an assessment? As Daryl was saying, it's one of the first tools that we run. The reason for it is because we have a pretty darn good success rate with it. We're getting anywhere between, nowadays, 40 to 50% success rate of actually getting credentials that give us a foothold in the environment. We use it to harvest the data and get that foothold. So once we get that foothold, I mean, that's the first problem that we always run into as pen testers. How do we get into the environment? Because once we get in the environment, then it's just a matter of time before we get those elevated credentials. So after talking to Daryl for a while, we're like, what can we do to make Prada better? How can we beef it up faster, make it easier for people to work with, get more people contributing to it? So we started talking about integrating it into Metasploit. And here are some of the reasons why we chose to integrate it. First of all, it's easier to maintain in Metasploit, and there's less dependencies to deal with. The current version of Prada is written in Perl, so there's a lot of times where you have to install CPAN, use CPAN to install modules. Sometimes the modules don't work and such. There's a lot of dependency issues that happen sometimes between certain things on Ubuntu versus a Mac versus Windows, all that stuff. With Metasploit, it's a lot easier to deal with. All the required libraries are usually packaged within Metasploit. We also have the ability to access a lot of the Metasploit APIs. So a lot of the things that are difficult to do, like handwriting SOAP interaction, now becomes easier with Metasploit because it has a lot of those API functionality that we can use to call out. Another great reason is once we capture that data, we can store it within Metasploit. We can look at storing it into the creds database. So it gives us advantage of being able to use it for reporting, find out which creds we have, find out what systems, and then kick that out to the customer and say, hey, look, here's all your systems, change all these default passwords. Another thing that we can use is reuse those credentials. Use it for pexec or some other form of brute force against different systems in the environment. And one of the other tremendously huge reasons to look at Metasploit is the large community base. People like out here. Who here hasn't heard of Metasploit? Okay, I have 2, 3, 4 hands. 5 hands way in the back. So I mean, most everybody knows what Metasploit is. Most everybody has seen it, used it, worked with it. It's a very simple tool. The framework, Metasploit Pro, the GUI interface, very easy to use. And it's easier for the community to contribute back printer modules. Makes it easier with the API calls. Once you see the modules that we're going to show here, it's easier for you to take that as a framework and then add your own modules and contribute it back to the framework. So what Daryl and I did is we created Pradasploit. It's the mesh of both Prada and Metasploit. We've started developing beta modules that at the end of the slide, you'll see our GitHub repo. You can download those, start testing them out. They are in the beta, so we're still going through some error handling and some of those checks. But currently we have modules that will do the LDAP passback attack on a Xerox, extract the Canon or the Konica address book, and then we also have modules that will go through and enumerate users from Dell and HP devices.
And the Canon also.
And the Canon. In total, we have about 7 modules that are out there that will be ready for use. So let's take a look at a couple of these modules. First module here is a very simple one. It just extracts the usernames out of the printer and displays them to you and saves it off the file. This way it makes it a lot easier. You don't have to go write these down by hand. You can start tallying these up and then catting the files and then using those files for a brute force attack. The next module is the Canon, where we're able to extract the address book information and get those credentials. So here we have the username and password and the file share that it has access to. And we also save the entire address book out to a file for any other type of information you want to pull out of there, like users or email addresses or anything like that. The Konica one, this one was a fun one. The reason why it was so fun is we took a lot of that SOAP interaction that you have to sit there and fiddle with and make sure you get the versions right, get the password right, form the message correctly and all that stuff. Yeah, let's not deal with that. So what we did is we automated it all. It's all in there. So it's able to go and find those version numbers, populate it correctly, put in whatever password's being used, either the default one, which is pre-populated, or another one if you're able to brute force it, and then makes those SOAP messages for you. So you don't have to go through and run it through Burp or any other tools. And we're able to extract the information from the address, or the address book. So we're able to get the username, the password, and what shares and machines it has access to. I mean, as a pen tester, this is tremendous to have this information readily available to me so I can start using these systems to look what information are they exposed on any system. Is this, FTP server, or they have sensitive information? Can I also use this account on other systems in the organization? The last one here I want to talk about is the one where Daryl showed up on the screen, the firmware attack, where we're able to create a custom firmware job that finds out that password, and then lets us know. So when we run this job against the system, it automatically already has that package already inside of it. It goes, deploys it on the system, searches that configuration file Daryl pointed out, and pulls out that admin password and gives it to us. Now that we have the admin password for the device, we can go back now and run the Xerox LDAP module and get those LDAP credentials and gain access. So what's the future? What are we going to do with Parade Exploit? Well, obviously, we're going to keep adding additional modules. We're going to convert a lot of the current Parade modules over into Parade Exploit. We're also going to be developing new modules. As we see new printers, new functionality that we can take advantage of, we're going to develop those and get those into the framework. We're going to take Parade as itself and kind of strip off some of the exploit functionality and just have it as an embedded device scanning engine. So what it's going to do is it's going to go through the whole environment and scan for embedded devices, not only printers, but also other devices like F5 devices that may have password leakage via SNMP, or APC devices, other systems in the environment that may give us additional access. And what we're also looking to do is have it set it up in a way that has the ability to call out to Metasploit. So you're not having to go through a text file and say, okay, I need to do these modules one by one. Hopefully, we'll be able to get it to the point where Parade runs, finds everything, and it starts launching all these modules for you. So at the end of several minutes or whatever, depending on how the environment is, you now have all this information that you can leverage and use. Now that we've kind of talked about how to go through and pillage and pwn the environment and get all this information, what can you guys do to protect your environment? What options, what configuration settings, what's the best way to deal with this stuff?
So how do we secure yourself? How are you going about securing yourself? I think some of the most critical things we've talked about is passwords. We have a number of ways of getting around passwords on several different printers. I don't think we've mentioned them all here. Obviously, the big one is the Xerox. We can use a firmware attack on a large number of Xerox. And I know there's a number of other firmware attacks against Xerox and some other printer types that can give you that level of access. This is not the only one here. But probably one of the big things is actually disabling firmware upgrades. If your printer allows remote firmware upgrades, disable that functionality and then change the password. Those things, two things combined, will probably secure you in the case, especially the Xerox, maybe some other brands. But it is most critical that your default passwords are changed. I've been doing this long enough, I probably got 3/4 of them memorized, so I don't even have to look them up anymore. I just log into your printer and steal the data. The other things we want to look at are patch management. Now, over the years, like I said, me and Pete's been doing this since 2010, and we haven't talked about any vulnerabilities today, but we've discovered probably a half dozen different vulnerabilities in various printers that we've leveraged to steal data. Some of those are actually built into the tool Prada and are automatically done, and they still work. Why do they still work? Well, I ethically disclose this stuff to the vendors, and they have fixed it. The problem is you haven't patched it, and that's what's going on. And also, don't expose to the internet. So how many people expose their printers to the internet?
You'd be amazed to see how many printers are exposed via Shodan.
Anyone here work for a university? Oh, you expose your printers to the internet. You may not. But universities are horrible at exposing their printers to the internet. So it's kind of amazing. Another cool thing is functional isolation. This is a big thing I like to talk to customers about. If you have multifunction printers that are used like HR, payroll, let's isolate these, okay? Because we know what you're printing on them. We know the kind of data, and we've only talked about stealing creds. We haven't talked about stealing data. So if you have these printers in HR and payroll, they should be isolated so that people that aren't payroll or HR authorized cannot get access to the management consoles in these devices. Because there are ways to set up printers to redirect print jobs to other places. So you can log on and set up a printer and say, hey, I want you to send this print job to, I don't know, pick a country. We're all out hacking each other, so, you know. French are sending it to the US, the Chinese are sending it to Russia, the Russians are sending it to the French, I don't know, it's going all over the place. But let's actually isolate these so that stuff doesn't take place. Have anything else to add to that, Pete?
And make sure, I mean, if possible, disable the manage interface or apply ACL so that only administrators of those devices can access it. Questions?
So we have any questions here? Yes, sir.
With the Xerox firmware, what's the state of the printer after that hack?
With the Xerox hack, what is the state of the printer during this? Actually, I actually did this hack while my company was using their printer. They didn't even know I was doing it. All this stuff was developed on a corporate printer. And the printer keeps working. Now, if you look at actually a firmware package and you read what Xerox says, it says the firmware will lock everyone out. It'll lock everyone out and then it'll force a reboot at the end. That's the full firmware. And then there's one that's just a patch, won't lock anyone out and it won't reboot. And then there's several versions. There isn't a single version of the firmware. The truth is that's all part of the executing code, whether people get locked out. We're not executing code other than the basic bootstrap that's supposed to kick the whole thing off. So it just shows up as a print job, spooled in the printer, and it continues running.
And the Metasploit module that we created, once it applies a firmware patch, grabs the credentials, it goes through and removes that patch. So it's just like the printer was before you even touched it.
Any other questions?
Lots of the stuff you mentioned seemed to be like functionality.
Yep.
So how much of that did get patched?
Functionality never gets patched. It's functionality. Now remember, we said this only works 50% of the time. You know, to me, the worst part of it is the company who's just spent $15,000 for a printer, and the only thing they do for it is print. So where do you think the biggest travesty is there? To me, that's insane. So the whole idea is let's secure the printer so those functions could be used securely. And it's all there. All the methods are there to secure these printers effectively, other than vulnerabilities. If it's a true vulnerability that exists, that's where patching is going to come in. And we know everything's vulnerable, and there's always going to be vulnerabilities. So we don't need to worry ourselves about that. We just need to use the security that comes with the device, even following some of the vendor's recommendations for securing it, and then the device is secure. And then you can use all these massive features and functions without any major risk taking place, in my opinion.
Any other questions?
Hi, did you try those attacks remotely or it was on site?
Oh, the Xerox?
Yeah.
With the Xerox, I've actually, if I can get access to port 9100, no matter where the device is, I can get the shell back. The cool thing is, and I know this is doable, I've done enough research, it is possible to potentially embed this into a print job. So if someone wants to take the time to develop that, you can put it into a print job. Let's say it's a coupon for a free sandwich at the local sub shop. Email it to everyone in the company, and ever who prints it to a vulnerable Xerox, have it kick a remote shell back out over the internet. And I've actually done that. I've actually made sure, hey, can I get out? It's all about egress filters. You know, the printer wakes up, it runs the job, and off it goes. It's going to connect, and I've connected back across the internet with this before, and I've connected to Xeroxes that were exposed to the internet during tests where I had access to the device because they had port 9100. Sent it there, it kicked me a shell back, and I was into the internal network. through the Xerox. It is doable.
Cool. If there's any other questions, Daryl and I will be around all afternoon.
Thank
And
you
thanks
very
for
much.
coming.